Good morning, everyone. Thank you for joining today. My name is Veena Rajarathna. I'm a product manager on the Kong Gateway team. I joined Kong recently. It's been about 3 months. Prior to Kong, I was building API management solutions at Nginx. And before Nginx, I was at Palo Alto Networks. Today, I'm presenting on API security and in particular, OWASP Top 10 for APIs. Here's the agenda. First, we'll look at the importance of APIs and why API security is a hot topic today. Next, we'll look at OWASP Top 10 list, what OWASP is all about, how they contribute. Then we'll review the top 10 items from the list and how Kong can help mitigate those. And we'll conclude with how organizations should consider their API security strategy. There's no denying that today's world is connected by APIs, right? So APIs have become the building blocks. They have seen tremendous adoption and growth over the last few years. So modern apps are built API first. Organizations are embracing API first or API-led strategies, mainly because APIs help teams build new digital services in innovative ways. They help accelerate and bring those services to market on time, able to collect feedback and quickly iterate on it. And APIs are not operational anymore, right? They are the business, they are the product, and they generate substantial revenue. So APIs have become very critical to businesses today. The rapid adoption is great for businesses, but it also presents challenges that the organizations are not ready for, right? They are an attractive target for attacks and data thefts, right? Because they're mainly dealing with exposing access to data and services. Today, the APIs are a number one attack surface, and they're evolving and rapidly changing as well. Insecure APIs are a threat to any organization. Once the APIs are compromised, they can cause lateral movement and disrupt the entire business operation, leading to loss of customer trust, damaged reputation, and financial loss for all parties involved. Securing APIs is not an option anymore, it is a necessity. When it comes to API security, the organizations have an overarching goal, right? They need to protect the data and the digital assets, they need to preserve customer trust, and they need to prevent financial loss. So how does OWASP fit into all of this, right? OWASP is an acronym. It stands for Open Worldwide Application Security Project. It's a nonprofit foundation formed in 2001. They are a highly respected community within the application security space. They are open source and they are community-led, so they encourage everyone to participate and contribute. So the foundation mainly works to provide information, tools, and resources to help organizations and individuals understand the security vulnerabilities and risks. They also help provide guidance and in addressing these risks. Last few years, they have been publishing the top 10 list to raise awareness of the most critical vulnerabilities the web applications face. And it's not limited to just web applications, right? They have expanded the list to include top 10 for IoT, for mobile, for APIs. They also have top 10 privacy risks, and there's a new entrant, top 10 risks for LLMs. Right, OWASP recognized that API is one of the fastest growing attack surface. So they released the top 10 list back in 2019. Since API security landscape is evolving rapidly, they came out with an updated list this year in 2023. Here's the list for 2023, the top 10 security threats for APIs. As you can see, authorization and authentication continue to be on the top of the list for many organizations. The three of the top five have to do with authorization or access control. Right. So compared to the 2019 list, they have introduced 4 new categories into this list, and 3 are expanded or either merged with other existing categories. We'll go over each of these items in the slides, in the next few slides. We'll look at authentication first, and we'll combine 1, 3, and 5, which are related to authorization in a single slide. So authentication is second top threat on the list, right? Authentication APIs are typically targeted because they are open to the public. They are publicly available. You say authentication is broken when a user can assume an identity of another user, right? Weakness in the authentication flows or the lack of authentication altogether contribute to this risk. Since APIs are meant for programmatic interactions, some of the protections that exist for browser-based APIs or mobile interactions are not available to APIs. So you have broken authentication if any of the following is true, right? There's no rate limits, or you don't have any kind of account lockout mechanisms on your authentication APIs, right? So typically login APIs accept username and password. They can be vulnerable to credential stuffing, password spraying, and other types of attacks, right? Wherein the bad actor is going to try, because there are no limitations or no account lockout mechanisms, they are going to try millions and millions of username and password combinations that are available. And with the password spraying, typically people use reuse passwords, so it's very easy for them to keep the same username and keep trying a different password until there is a hit, right? So your APIs are vulnerable if any of this is possible. Second, it's the incorrectly implemented authentication mechanisms. Even if APIs are using token-based approach, they are vulnerable as well, right? So the implementation may be incorrectly implemented, wherein you're not checking for the expiration, you're not checking for, you're accepting unsigned JOTs or poorly signed JOTs. So it's making use of those weaknesses in the cryptographic weaknesses. Third is the poorly implemented session management, where session IDs are reused. Before authentication and after authentication, you end up using the same session ID, or you're not rotating or invalidating those session IDs upon logout, not setting the session length, or simply the URL may be returning the session, the session ID in the URL. So all these are, various different causes of broken user authentication. Next up on the list is the authorization. So there are 3 categories: API 1, API 3, and API 5. They are the top 3 of the top 5 authorization-related vulnerabilities. So in software, everything is abstraction, right? And we use the concept of objects to represent data. See, object-level authorization is an access control mechanism to ensure that the user has the right permissions to access the objects and handle the objects. So any action on that object should implement object-level authorization checks, right? It's like making sure that the logged-in user has access to perform the requested action on the requested object, right? And we say authorization is broken when unauthorized changes can be made in the system. Typically, APIs are handling objects and object identifiers, and as a result, it's a wide attack surface with regards to access control. Right, this kind of vulnerability will lead to horizontal privilege elevations, where users are accessing other objects that they're not permitted to. They may be performing privileged actions and seeing excessive data as well. So we look at this with an example. So imagine an API, an Airbnb-like application, and you have an API that accepts reservation, right? So there are 2 types of users in this system. There's a guest user and a host user, right? If your guest is able to access an API or an object that only host user is supposed to have access to, then you have broken function level authorization issue, right? So in this case, if the guest user can accept the reservation, then it's a broken function level. So let's say you fix the broken function level, and the next one is your host is accepting the reservation. And if there is an ID associated with that reservation, and if you're able to, in this case, we're showing a simple ID, and if your APIs are using simple IDs, or if they're able to change that ID and get access to another user's object, then you have a broken object level authorization issue. So next up on the list is a new category, which is the property level. So now maybe you have taken care of ensuring that only objects that users have access to are being accessed and modified, right? But with this new category, there might be some properties on that object, even though the host owns it. Some properties should not be changed, right? Like in this example, there's a total price on that reservation, which should not be modified by the host user after accepting it, right? So if they are able to change that, then you have a broken property level authorization issue. So this is a simple example to show the authorization issues, the top authorization issues. Next up on the list is unrestricted resource consumption, right? To process API requests, you need resources on the back end, like CPU, memory, storage, bandwidth, and whatnot, right? And the input to the API and the business logic of that API will determine how much of the resources are needed to fulfill that API request. API requests typically do not restrict the size or the number of resources that can be requested, and hence this vulnerability is number 4 on the list, right? Lack of any kind of restriction can lead to outage or can lead to denial of service type of attacks, right? Lack of resource restrictions, you don't even need high volumes of API traffic, right? With a single request that is well crafted, you can bring down the whole system and render the application unresponsive. And this is an application level DOS, right? And an example is an incident at the SoundCloud. They had a tracks endpoint which accepted an array of IDs as query string parameters, right? And there was no validation on the number of IDs in the list. So API could be crafted to retrieve a large number of tracks, and that could overwhelm the system, right? So, and under normal operations, SoundCloud application would see 16 IDs or so, and in this incident, about 689 tracks were requested, and that kind of overwhelmed the application. And without any kind of rate restrictions, right? If you don't have any type of rate restrictions on your APIs, several API requests could be sent simultaneously or in rapid succession, and you can exhaust the system resources and render it vulnerable to other types of attacks. So an example is a forgot password flow that uses an SMS, right? This incurs financial loss because you're triggering those number of third-party SMS requests that end up charging, leading to financial loss. Number 6 is unrestricted access to sensitive business flows. So in this case, the traffic looks legitimate because they are actually accessing a legitimate API or a valid business flow, right? So this is about finding that sensitive flow and automating against that flow, which can, in the end, cause harm to the business itself, right? For example, let's say your APIs are exposing purchase workflows or reservation APIs. So there is no technical impact, but it does hurt the business in different ways, right? It causes legitimate use of it prevents the legitimate use of the service. You can incur financial loss, and you can actually game this in your favor. For example, if a simple example is comments API, right? If there is no, this system could be, you can use it to spam the system, sending a lot of comments, and you could negatively affect the reviews, right? Or a reservation API wherein you take up all the slots that are available, rendering nothing being available to legitimate users, right? For example, there was an attack on the airline system where airline tickets were booked because and later canceled because there were no logic to support to block this kind of consumption. Number 7 is server-side forgery request. This is a new category. Even in this case as well, the request itself is valid, right? So there are APIs that accept user input, right? Most APIs, and one of the inputs could be a URL field, right? And when the request is being processed, the backend then fetches. There's no validation on the legitimacy of that URL. So the API backend then fetches that resource, which could be a malicious script, or it could be forced to go to an unexpected destination, right? Opening up the backend systems to that unexpected, to the bad actors. So this is a growing type of attack, and hence OWASP has added it to the list. An example of this is a social media upload functionality, right? So it allows you to upload pictures wherein you can provide a file or you can provide a link to fetch the file, and attackers could insert malicious URLs in those links, and typically there's no validation on the legitimacy of that URL. Number 8 is security misconfigurations, right? Misconfigurations can happen at any level, network level or application level. Sometimes people make mistakes, right? Like leaving default settings, which may be insecure, or not having misconfigured HTTP headers, or unnecessary methods being available, or they may not be treating configuration as code, and they may be making ad hoc configurations now and then and totally forget about it, right? Leaving it wide open. The course may be too permissive. The error messages may be too verbose, giving out sensitive information. And in some cases, response headers may be missing, cache control headers may be missing in the response, which leads to the API responses being cached, and those API responses may have sensitive data, right? So attackers are looking for services running with default settings or unpatched systems and flaws to gain access. So a small error during setup can lead to the entire server being compromised. Improper inventory management. This is again another new category in the 2023 list. A lot of organizations are facing this challenge, right? First and foremost, they have no visibility on what APIs they own, right? So how many APIs are in production, how many are in other test environments. So they have no visibility. So they're not really monitoring those APIs. Because of the nature of developments, APIs come and go, they become quickly abandoned, and they are a big security risk, right? And if you don't know what you own, it's hard to monitor it and collect metrics on things that you retire the APIs or keep them running. So you end up having multiple versions of the APIs, even when they are supposed to be deprecated, right? So this is a big security risk, and not knowing what you own and not knowing what to protect and monitor. Number 10 on the list is unsafe consumption of APIs. Again, this involves abusing third-party integrations. Today's connected world, APIs talk to other APIs. They interact with APIs all the time, right? There are two types in this category. So one is the consumption of the API data itself. So when your application consumes another API blindly, the data returned by that API blindly, you're trusting that other service, and because either it's from a well-known company and you're not adopting proper standards, right? So you are not sanitizing the input or validating it, and that could be a huge risk, right? And the second is the integrations, right? So today we have so many integrations available, and with few easy lines of code or a few clicks, we can add that to our application. So third-party integrations are the weak link because they are hugely unmanaged or unverified code, You don't really own it. And attackers are looking for vulnerabilities in these third-party software as well, right? So Log4Shell incident was an example of that. So unsafe consumption of APIs in the Log4j library is a very good example of this category. So how can Kong help, right? So API gateways today have become a very essential component in the technology stack, right? Similar to the firewalls and the WAFs, gateway has its place, right? And gateways provide an active layer of insulation, right, from security attacks and other events, as well as the demand surge. They act as protocol mediators, right, between the consumers and producers of APIs. They can enforce security policies, and additionally, they can provide metering and telemetry capabilities for offline analytics. Right, as we saw, the OWASP top 10 list is mainly highlighting the design flaws of APIs or implementation flaws and unsafe practices seen throughout the industry. Right, there's no alternate to a well-designed API or well-implemented API, but the gateways themselves can't fix that bad implementation, right? But they can offer a runtime protection, and they can help bring in that governance at the infrastructure layer and provide that additional layer of security. So let's look at some of the key plugins that Kong has and how they can offer protection, right? So broken authentication, right? So Kong offers number of authentication plugins depending on the maturity of the APIs, right? The organization can use one of the many plugins. If you're using token-based, there's the JOT validation plugin. You can ensure that the token expiration is checked. You can configure other types of checks as well. Making sure that you don't accept unsigned JOTs or you don't accept poorly signed JOTs. You can use the rate limit to enforce limitation or protect the authentication endpoints, regardless of whether your API implementation is handling it or not. And your platform teams can enforce better secure authentication mechanisms such as MTLS auth as well. For broken authorization, again, Kong offers many choices, right? As a way to standardize access control, you can have fine-grained access control can be enforced with OPA, the Open Policy Agent. You can use OIDC plugin, offload access management outside of the API implementations. If you don't have any of those, you can build RBAC, you can build access control on top of Kong using consumers and consumer groups. For the unrestricted resource consumption, Kong offers rate limits to protect your backend services. So you have some gating, limiting at the gateways. You can also limit the size of the payloads with the request size limit plugin. For the unrestricted access to sensitive business flows, this is a partner play, right? So Kong offers a variety of exporters for both logs and metrics. You can export the API logs, API metrics to an outside system where you can monitor, analyze the traffic, and create alerting systems to track anomalies. SSRF. SSRF is one of the leading, the commonly found attacks these days. So you do need some other measures. What Kong offers is, you can use the request validator plugin to validate the request against a schema. This is not going to solve the case where you're using legitimate URLs, but the URL, the format of the URLs are right, but the URL could be pointing to a wrong domain. For security misconfigurations, there's the course plugin through which you can control the origins for the browser-based plugins to fetch resources. You can build an allow and a deny list with IP restriction plugin for both HTTP and TCP traffic. You can enforce communication happens over encrypted channel using the TLS. And Kong, at the core, Kong offers some security measures out of the box, right? Like standardized response headers, disabling fingerprinting, and all these security misconfigurations that are seen out in the wild can be avoided. For the improper inventory management, Kong is about lifecycle management, right? You can manage the lifecycle of APIs starting from publishing all the way to retiring. Same for documentation, right? You keep the documentation in sync with APIs, retiring documentations when you retire APIs. You can build the service catalog and manage the lifecycle of the services. And you can use the design tool, API design tool, to test and design and develop the APIs through the lifecycle. Unsafe consumption of APIs, again, this is something that the third parties originates in the third parties. So using request validator plugin, you have some capability at the gateway to validate those requests are adhering to the schema. You can use the log and metrics exporters to export metrics and logs and monitor for anomalies. So to summarize, organizations need to adopt a holistic approach. Security is better in layers, right? So I don't want to be in the constant mode of discovery, right? So you want to get a head start, adopt a positive security model, build that API visibility, use an API governance, bring in API governance using an API management tool, define standards, practices, so all your teams can adhere to that, and incorporate continuous security testing, right, throughout the life cycle, the development life cycle. Defense in depth is great, but moving towards zero trust is even better, right? So you layer in protections at every part of the architecture, so you prevent those lateral movements, block volumetric API abuse with the right tools, and you stop those OWASP top 10 attacks, right? And establish a baseline for both normal and abnormal traffic with some continuous monitoring, and you can detect anomalies. And be proactive about threat prevention, right? So invest in tools to detect and block malicious activities in real time. That brings me to the end of my presentation. Thank you for joining and have a great time at the API Summit.